Okay, so empirical molecular formula is not hard, but it's a step-by-step process that you have to follow. So I'm going to show you the steps. I'm not going to read through this, but I'm going to show you the steps is easier than reading the steps, and you're not going to understand it until you see it. Okay, so we're going to just, that's there for if you want to refer back to it. Okay, so this is like we did percent composition. This is going to be like one step further. Okay, these are all the steps we want. When we're doing this, we want it to at least 4 significant figures. That's going to tell you what I'm going to show you. Showing you is usually easier than telling you, and then you can go back and refer to those steps, and it'll make sense because you saw it in action. Okay, so the basic steps are you're going to convert percent to mass, mass to mole, divide by the smallest, and then multiply till you get a whole number. Okay. Sometimes your data will be given to you in grams, like you have this many grams of carbon in the sample, this many grams of hydrogen, etc. Sometimes it will be given to you as a percentage, like the sample is 25% carbon. So what you would do to go from percent to mass is you are going to assume 100 grams. Because if you assume 100 grams and you have 25% carbon, how many grams of carbon do you have? 25. Yeah, so it makes it easier. So if they don't give you a sample size and they give you percentage, just assume 100 grams. Okay? But before we actually show you how to do this, I want to make sure you understand what the difference is between empirical formula and molecular formula. Okay? Your empirical formula is the simplest ratio of elements. Okay? So for instance, I have this substance of benzene. Okay? Can I simplify that formula? Yes. How would I simplify it? CH. Okay. This would be the molecular formula. This would be its empirical. Another compound, C2H2, which is ethine. If I simplified it, what would its empirical formula be? CH. So same thing. Because if I were to go into a lab and do percent composition of either one of those, I would get the same percentage of carbon to hydrogen, even though they're different compounds. But in percent composition-wise, it would be the same. Okay? And so that's why we use our percent composition to calculate its empirical formula. Okay? It's a second step to calculate molecular formula. Okay? Sometimes you can have its molecular and empirical formula are the same thing. Okay? For instance, if I had this compound, C3H7, can I simplify that? No. So its empirical would be the same as its molecular. Okay? For ionic compounds, they only have an empirical formula. Why is that? They're already simplified. In ionic compounds, they can only go together in one way. And molecular formula implies that we have what? Molecules. And what is the only thing that forms molecules? Covalent. Yeah. So just want to make sure y'all understand that. Okay? All right. So we're just going to dive right in. And this is where I would suggest if you have different color ink pens, you might want to do it. Only change when I change colors, okay? Only change when I change colors because I'm going to show you the steps, okay? So this is already in grams, so we don't have to assume anything because we're not in percentages. So we're going to underline the 4 things that we have in this compound, okay? Since it's already in mass, the next step said to convert all of your mass to moles. Who remembers how we go from mass to moles, grams to moles? What do we need to use?
6.022.
Incorrect. Okay? Do not use Avogadro's number anywhere in this unit. We do not need it in this unit at all. What do I do to go from grams to moles? We did this earlier in the year. Molar mass. We use molar mass, okay? So we're going to write down each one of these. We have 542 grams of carbon. So we're going to divide by that molar mass. Why is it doing this? Oh, hold on. I forgot. Yeah, sorry. I used the wrong thing for hydrogen and carbon. So sorry. Y'all gotta keep me honest up here. I forgot this right here. My bad. 22.430 grams of carbon. I'm so sorry. 12.01 grams of carbon, 1 mole. Now, I started with the wrong thing. I apologize. What's the molar mass of hydrogen? 1.01. Have y'all started memorizing those on accident? Yeah, you use them enough. 44.8598 grams of oxygen divided by, what's that molar mass? 16. And then lastly, we have 26.1682 grams of nitrogen. And what's the molar mass of nitrogen? 14.01. So now everybody go and do that. This forces me to slow down. Go and calculate all of those moles. You want 4 significant figures when you do this part. It's more accurate for this. I mean, if you have to have at least 2 or 3, because otherwise your ratio is going to be off. If you don't do enough, your ratio can be off. And y'all please double check me, because I am the world's worst about transposing numbers when I put them in the calculator. Now this next step would be a good time to change colors, because the next step after you convert everything to moles is to divide everything by the smallest number of moles present. Okay? So you're going to divide everything that you just put into moles by the smallest number of moles present. In this case, we have 2 that are the same. They happen to be the smallest. So we're going to divide everything by the 1.868. This is going to give us our ratio of atoms. So obviously nitrogen is going to be 1 and carbon is going to be 1. But we get hydrogen as 3.5, and we get oxygen to be, I think it was 1.5. Nope. I'm going to tell you what you can't round that. It's too much to round. Okay? So what you have to do, because I cannot have 1.5 atoms, doesn't work. There's no way I can put 1.5 atoms in a compound. So I have to, this is where we're going to change colors again, I have to multiply by an integer. It'll come back. I have to multiply by an integer to get a whole number. So I'm going to multiply 2. What I do to one thing, I got to do to all of them. So I'm going to multiply all of these, there goes my calculator, by 2. Because you can't have half an atom. So you have to multiply by an integer. Okay? So then that becomes 2, 7, 3, and 2. So my empirical formula for this compound would be C2H7O3N2. And to signify that it's an empirical formula, we're going to write it like that with a little N. Because we don't know, that could be its molecular formula or it could just be its chemical formula. I'm going to show you how to solve for N in a moment so that you can figure out what the molecular formula is. That's actually the easiest of all the steps. Okay?
So why are we multiplying by 2?
Because right here, I cannot have 3.5 atoms and 1.5 atoms. So I have to multiply by an integer to get it to be a whole number.
We just choose 2 because...
Well, because 3.5 times 2 is a whole number. No. Okay, so if it had come out to, like, say 3.33, what would you multiply by? 3, and that would give you a whole number. If it comes out to 0.25, you'd multiply by 4, right? So that's depends on what it is. Now, if you calculated that and it came out to, like, 1.07, that's close enough to 1. It's when you start getting like 0.25 and above, you need to do that. Yes?
Why did you divide by 1.2?
Because you divide everything by the smallest number of moles you have present. And so it was, for both carbon and nitrogen, that was the smallest number. So I divide everything by the smallest number of moles. That's the step. That's the next step after you convert everything to moles. Okay? And if you look through the steps, it tells you after you do convert everything to moles, then divide everything by the smallest. It's how we figure out what our ratio of atoms are to each other. Okay? Any other questions on that problem until we're going to go do another one in a second. Okay? We talked about this first period, so incidentally, I want to tell you guys this as well. Your test next week is, well, I don't think it's hard, but but it is, there's not any multiple choice. It's all free response. Okay? So I'm going to tell you, it's basically this. You've got 40 points is your naming and formula writing. So you've got 10 formulas to write, and you've got 10 names to write. So that's 40 points, 2 points each. Then you have 6 problems worth 60 points. However, they're not 10 points each. There are 3 5-point problems. There are, I think, 1 10-point problem, 1 15-point, and 1 20-point. And there is partial credit, okay? And this one right here, if you're doing an empirical formula, this would probably be a 15-pointer, okay? Because this takes a lot of work to get there, okay? It takes a lot of work to get there, okay? In a second, when we do the whole thing, I'll show you what a 20-point problem is, okay? Do what? This is a brand new test from last year. I just finished writing it. Okay? I highly suggest that you know your polyatomic ions, okay? Because if you don't know your polyatomic ions, you're not going to do well on the naming portion. Okay? So if you were already supposed to do those. We did the quizzes, and we did the quiz before Thanksgiving. But if you don't know those, that's 40 points that you could mess up in. Okay? So, let's do some more problems. Alan, these will be on Canvas by the end of the day so you can see what you missed. You'll hear all their complaining. Yeah. I may change my mind and record 5th period instead. Okay. All right, let's do another empirical formula. This one has 26.8% tin, 16% chlorine, and 57.2% iodine. Since we are in percentage, we are going to assume 100 grams. Okay? When I assume 100 grams, now how many grams of tin do I have? 26.8 grams of tin. I'm going to divide that by its molar mass, which is 118.71. And then that means we would have 16 grams of chlorine divided by 35.45. And then 57.2 grams of iodide, which is 126.90. Now, I want to caution you on this. You better be writing these units down when you're doing this. Don't just put numbers, because you will lose points for that.
Is that 90 on the bottom?
That's 126.90. Yeah, I'm kind of running out of space down there. It's hard to write down there because it gets to words. Okay, so now let's do all that math real quick. 26.8 divided by 118.71. We need 4 significant figures here, so we're going to say 0.2258 moles of tin. 16 divided by 35.45 gives me 0.4513. Yeah. moles of chlorine. And then iodine gives me 0.4507. So what is my next step after I put everything into moles? Divide by the smallest, which is 10. So divide everything by 0.2258. So that's going to be 1. This comes out to 1.998. That is 2. This one comes out to 1996. That's also 2. So that my formula is going to be SnCl2I2. Now this one, because there's a metal present, would not be a molecular formula. So that's going to be my formula for this compound. Okay? Because I've got a metal, that means it's an ionic compound, and there's only one way for these things to go together, and this is it. Okay? Now, someone earlier asked me, well, then do we even need to do it because it's got to go together? I'm like, yes, you still need to do it, because how do you know it wasn't 1 iodine and 3 chlorine, or vice versa? Or let's say I had something like, you know, phosphorus and oxygen with 10. How do you know it's phosphate or phosphite? You would not know that unless you did the empirical formula. Okay, so you still, even though it's an ionic compound, you still need to do it because you don't know which polyatomic it could be or which ratio of the elements. Okay? Yes?
If you were to like name this in 3 parts, would you just say 10-4 and then
10-4 chloride iodide. Honestly, someone made this problem up. That doesn't really exist very well.
very well?
Yeah, I don't think it. It might. Yeah. All right, so now let's do molecular formula. That's the easy part. Any questions before I erase this? Okay. Is anybody lost, dazed, and confused, or do you tentatively know what's going on? Tentatively. I can't say that word. Tentatively. Okay. So, molecular formula. Okay. This one's telling us the molar mass of a compound is 181.5, and the empirical formula is C2HCl. What is its molecular formula? So we're going to go ahead and say we know that this is our empirical formula. And remember I told you we write it with that little N? Because I'm going to tell you how to solve for N. Okay? N is the molar mass, which you will always be given. It has to be discovered or calculated or experimented in a different way to get a molar mass. It's different than percent composition. And that's divided by the empirical mass. Okay? Your number on the top will always either be the same or bigger. So if you ever put a smaller number on top, then you've done it wrong, because it'll never be a smaller number on the top. So we're going to put what they gave us, 181.50. Does anybody want to venture to guess what the empirical mass is? If I said you got to guess or you get a 0, what would you guess to be? What do you think the empirical mass is?
60.48.
Okay, let me ask that a different way. How do you think you should calculate an empirical mass? Exactly how you do for molar mass, except for the empirical formula. You know what? That's a good answer. You get a starburst. Okay? Okay, so we're gonna calculate the mass of this. Just like we would do molar mass, it's just called an empirical mass because it's an empirical formula. So 12.01 times 2 plus 1.01 for hydrogen plus 35.45 for chlorine, and you should get 60.48. And I don't even have to put that in the calculator. What's it going to come out to be? 3. Okay? So now we take that 3 and we plug it in for that N. So then our final formula would be C6H3Cl3. And that would be my molecular formula.
Is that because you distributed it?
What?
You distributed 3.
I multiplied inside by that 3. Is that what you mean by distribute? Okay. Because anytime you have something outside parentheses, everything inside gets multiplied by it. Okay? That's a math term. I don't know the math. I just multiply. Yeah. Okay? So this problem, if you were to see this on a test and I gave you the empirical formula and I said, here's the molar mass, what is its molecular formula? This would be only a 5-point problem because this is easy. So this would be 5 points.
We do the 20-point problem?
Huh?
Yeah, what's the 20-point?
We're fixing to do one.
Is it where we have to find the empirical formula?
And then you have to do them both together. Yeah, that's gonna be your 20-pointer. You got to do them both together. Okay, this would be, now I'm going to tell you right up front, your 20-point problem on the test is going to have more than 2 elements. It's going to have 3 or 4, okay? This only has 2 elements. This is much quicker, much easier. But yours on the test will have more than 2 elements, okay? Okay, so find the empirical formula of a compound containing only carbon and hydrogen if it's known to have 84.21% carbon. So we're going to assume 100 grams. So that means we have 84.21 grams of carbon divided by its molar mass. Again, you better put these units down. Don't just put numbers. I will take off points. And what I mean by that is if you just did this, I would take off points. Because I don't know what you're doing there. You gotta put units on there.
Do we have to put the C for carbon?
Yes. Otherwise, how do I follow your work? Especially if y'all write messy. It's a little c. It's not that much effort to write. Okay? So if I have 84.21 grams of carbon, how much hydrogen do I have?
15.79.
And how did you figure that out?
I did it. I subtracted 84.21 from 100.
If you're asking
Give me a Scarborough.
That's okay. I will always encourage you to do mental math when possible. So this comes out to 7.011 moles of carbon. This comes out to 15.63 moles of hydrogen. What's my next step? Divide by the smallest, 7.011. 7.011, this equals 1. This equals like 2.23. Can't round. Close. It's close enough to 2.25, so what would we multiply by? 4. So then we're going to get 4 and... what's that one? 9. So our empirical formula would be C4H9. Huh? Well, yes, but it will have more than 2 elements. Okay, so now we're going to go solve for M, because the second part of that says if the molar mass is that much, how much is the molecular? What is the molecular formula? So we have molar mass over empirical mass. You will be given molar mass in the problem. Okay, so it's going to be 114 over, we need the empirical mass. How do I get the empirical mass? So I have 4 carbon times 12.01 plus 9.09 for hydrogen. So I get 57.13. That comes out to like 1.99, which is 2. So that my molecular formula would be what? C8H18. And that would be my molecular formula. So that would be a 20-point problem. Now, there's partial credit along the way, just like there's places where I can take off. I'm going to tell you right now, if you don't put units when you're doing your conversions, I'm going to take points off. Okay? Because when you go on, if those of you that go on to take AP Chem, it's necessary to do that. Okay?